welcome to Epsilon Pro Academy. In today's lesson, we are going to look at application of differential calculus. However, there are basic important concepts and terms we have to consider before stepping into calculations. So the terms are tangent and normal to curves. Now, by definition, a tangent to a curve is the line that touches the curves at a point. The line that touches the curves at a point. Now, let us emphasize a little bit on this. So, in mathematics or in physics, when we say change in y over change in x, especially when you are plotting physics graph, so what is the first thing that will come into your mind when you come across the word change in y over change in x? Slope, isn't it? Slope is also known as gradient. So in calculus, we can say that derivative or derivation is the rate of change of one quantity, say y, with respect to another quantity, say x. So that is to say, it is change in y over change in x. Change in y. So change in y over change in x could also be given as change in y over change in x could also be given as the derivation of y with respect to x, which is dy over dx. Now note that for any curve, the gradient of a function is always given as dy over dx. At any point in the curve, dy over dx at a point gives the gradient of the tangent at that point. So that is to say, the derivation of y with respect to x at a point would give the gradient of the tangent. Now let m1 represent the gradient of the tangent. Always note that at the point in the curve, dy over dx at a point gives the gradient of the tangent at a point, let's say AB, at a point, let's say A, B, A, B. Now, because M1 is the gradient of the tangent at this point AB, we can say that M1 is equal to the derivation of y with respect to x at this point, and this could be written as dy over dx at the point, let's say A, B. Now, I want you to note this. When we say at a point, when we use the phrase at a point, a position will be given. And in every position that is given, a Cartesian plane must be considered. So in a Cartesian plane, we must have the x and the y axis. The x and the y axis. So because you're having x and y axis in every position given to you, we must have a point labeled x, y. That is to say, if any position is given to you at a point, the first numerical value in the bracket represents that of x, whereas the second is always that of y. So in this case, at this point where we have A and B, that means this A is for x and the B is for y. So take note of this concept so that during calculation you will not suffer once. So we are going to consider a few examples under gradient of a tangent before stepping into normal of a tangent. Let's consider the first example on the board. The question is, find the tangent to the curve x squared y cubed plus yx cubed plus 2x minus 6 is equal to 0 at the point 1, 2. Now, whenever this type of question is given to you, this is the first thing we have to do. We are going to differentiate the function given on the board. That is the first approach. Then, after the differentiation, we substitute with regard to the position given. Now, how do we differentiate this function on the board? We observe that in this function given, both x and y variables are being mixed up. That is to say, we cannot solve this explicitly, but we can only solve this implicitly. This is an implicit function, and we treated this in our previous videos. So the link to the video will be on the description of this video and also at the end of this video. Now, to solve this function implicitly, we have x raised to the power of 3 raised to the power of 2 y raised to the power of 3 plus y x raised to the power of 3 and plus 2x plus 2x minus 6 is equal to 0 at a point 1, 2. Now, one of the basic concepts when it comes to implicit differentiation is that whenever we have both x and y variables together in a particular term, we have to differentiate twice. Yes, so we are going to differentiate first the x term on the board. And when differentiating this person, you cover this person. So if I'm covering this person, the only person seen on the board is x raised to the power of 2. So we are going to differentiate x raised to the power of 2. And that will give me 2x. Then multiply by this person. So that is, differentiation of this is 2x multiplied by this times y raised to the power of 3. Also, let us differentiate y term by hiding this term on the board. At this point, we are left with just y raised to the power of 3. So the derivative of this term on the board is 3y raised to the power of 2. Then multiply by this person. So plus 3y raised to the power of 2. Then multiply the result by this term that we covered. So that will become times x raised to the power of 2. The rule is that whenever you are differentiating with respect to the y term, add dy over dx to it. Let us consider the next term. Now, in the next term, we have yx raised to the power of 3. Yx raised to the power of 3. Now, the rule is that whenever we have two different variables, x and y, we are going to differentiate twice. So let's differentiate the first term, which is that of y variable. To do this, let's cover this person. At this point, if you cover this person, you are going to be left with just y alone, isn't it? So if you differentiate y, you obtain 1. Then we are going to multiply the 1 by this person, which is 1 times x raised to the power of 3. So we have x raised to the power of 3. Now the rule is that after differentiating y variable, always ensure you attach dy over dx to it. So now let's differentiate for x. If I'm differentiating for this person, I'm going to cover this person. So what is left is x raised to the power of 3. The derivation of x raised to the power of 3 gives 3x raised to the power of 2. So multiply by this. 3x plus 3x raised to the power of 2 multiplied by y, which is 3x raised to the power of 2y, plus, let's differentiate the next term, 2x, and the derivation of 2x is going to give 2, minus the derivation of a constant term is 0. This is equal to 0. Next is collection of like terms. We are going to bring the derivation of the x variables in one bracket and also the derivation of the y variables in another bracket. That is, this is for x, this is for x, and this is for x. This is for y, this is for y. So for x, we have brackets open, 2x y raised to the power of 3 plus 3x squared y plus 2 plus 2 plus, then the derivation of y variables is this, bracket open, 3y squared x squared, 3y squared x squared plus x cubed, then attach dy over dx. This is equal to 0. Next approach, we are going to move the derivation of the x variable over to the right hand of the equation. That is, we will be left with this bracket in the left while this person goes to the right. This bracket, 3y squared x squared plus x raised to the power of 3, bracket dy over dx will equal to, when this person crosses over the equality sign, it becomes minus. So we minus, bracket open, 2x y cubed plus 3x squared y plus 2. At this juncture, we have to make the y over the x the subject of the formula. Now, to obtain that, divide both the left and the right hand side of the equation by this, so that this will be eliminated. In bracket, 3x squared y squared plus x raised to the power of 3 dy over dx is equal to minus, in parentheses, 2xy raised to the power of 3 plus 3x squared y plus 2. Dividing the both sides by this. So we have 3x squared y squared plus x cubed, 3x squared y squared plus x cubed. So this would cancel this. We're going to be left with dy over dx is equal to minus 2xy cubed plus 3x squared y plus 2 divided by 3x squared y squared plus x cubed. Dy over dx becomes this. So the question is, tangent at this point. Now the gradient of the tangent to the curve is given as m1. And it was stated that m1 is equal to dy over the x at a point AB. But in this case, the point was given as 1, 2. So at a point 1, 2. In this position, this 1 represents x, whereas this person represents y. That is to say, in dy over dx, we are going to substitute 1 and 2 respectively into x and y variables, and that becomes the gradient of the tangent. So let's substitute dy over dx. m1 is equal to minus, in bracket, minus bracket open 2x. So this represents x, that is to say 2 times 1, then times 2 raised to the power of 3. That is for the first term, plus 3 bracket open x is 1 raised to the power of 3, 2, then y raised to the power of 1 plus 2 bracket close, all divided by 3 bracket open x, and x is 1 raised to the power of 2, y is 2 raised to the power of 2, plus x is 1 raised to the power of 3. 2 raised to the power of 3 means 2 times 2 times 2, and 2 times 2 is 4, 4 times 2 is 8. So 8 times 1 is 8, and 8 times 2 is 16. So m1 is equal to minus 16. 1 raised to the power of 2 is 1. 1 times 1 is 1, and 1 times 3 is 3. Plus 3 plus 2 bracket close, all divided by 1 raised to the power of 1. 1 raised to the power of 2 is 1. 2 raised to the power of 2 is 4, and 4 times 1 is 4. 4 times 3 is 12. 12 plus 1 raised to the power of 3 gives 1. And the result becomes, in the numerator, 16 plus 3 is 19. 19 plus 2 is minus 21. Don't omit the sign. Divided by 12 plus 1 is 13. So the gradient of the tangent, say M1 is equal to minus 21 over 13. And that becomes the final result.